Is diarrhea mainly waterborne or mainly water-washed? Water engineers build water supplies to produce better health. The biggest health benefit from water supply is a reduction in the diarrheal disease, which kills millions of children in the developing world, particularly children under 5, and most of those even under 2. One question that engineers and others ask is whether the problem is one of water quality, that is, the bugs are transmitted in the water, people drinking the water get sick, or whether it's related to hygiene and water quantity, and how much water people use and what they do with it, particularly do they wash their hands. Now, it's very hard to tell which of these is going on because you can't catch a bug at the moment that a child swallows it and say, you were in a sandwich or you were in a glass of water. You have to analyze the data. Okay, the first kind of evidence is evidence from what I call negative health impact studies. These are studies trying to measure the benefit to health of a better water supply, which have ended up with negative findings. They haven't been able to find any benefit. And there's a surprising number of those. Now, the problem is that most of these studies are not very reliable. They all have something wrong with them. But let me show you the one that I think has least wrong with it. And the intervention in this case was not water supply, but people were given little bottles of chlorine and told how they could open them and pour them into their drinking water bucket. And this would disinfect the water. Chlorine takes about half an hour to work, but it would eventually disinfect the water. And there was a placebo group who got little bottles of, not chlorine, but just distilled water, which they could pour in. It wouldn't do any harm, but it wouldn't make any difference. That way people didn't know which they were getting, and halfway through the two groups crossed over. And you can see, looking at this table, that the water quality is very different. The placebo group were drinking water with 16,000 fecal coliform bacteria per 100 ml. So in one wine glass of the water, 16,000 of these bacteria. So a lot of fecal contamination. But if we now look at the difference it made to diarrhea, the difference was almost nothing. And in those days, negative trials like that were very hard to publish. I think this one got published back in 1982 because not only the authors, but the editor of the journal were astonished by what they found. The second kind of evidence is the microbiology of food, particularly food given to young children, who are the ones who get diarrhea and sometimes die from it in developing countries. We've just seen huge numbers of bacteria in water, but if we look at the number of the bacteria in food, they're often greater. Here's an example. This is a table taken from a study carried out in Gambia, where they visited households in villages in Gambia and took samples of the porridge that's given to children at weaning to start them off on food. And very often it's cooked, and the cooking should remove all the bacteria in it. But that's part of the problem, because once they've removed all the other bacteria, if the porridge, after it's cooled down, gets contaminated by somebody putting their thumb on the edge of the bowl or something like that, then those bacteria that have got back on there are in a kind of heaven, bacteria heaven, because there's lots of food, there's no other bacteria to compete with, and they can just multiply and make whoopee and grow. So if we look now at these porridges, what happens in a few hours after it's prepared, the mother cooks it up in the morning, and some of it is served up in the evening meal. It may be 8 hours since preparation. And you can see now this huge number of bacteria that develops far beyond the number in the water that was used to mix the porridge in the first place. That would lead us to suspect that food preparation and food hygiene is a much more important issue than water quality. The third type of evidence, and it's perhaps connected to the food microbiology question, is the seasonal pattern of diarrheal disease. And generally speaking, you get a greater rate of diarrhea and a bigger difference the more the difference in temperature. So if we look at the extreme, Lesotho in southern Africa is so far south that it's outside the tropical zone, has a winter with snow and ice. It's really cold and gets reasonably warm and hot in the summer. And the seasonal pattern of diarrhea is much more pronounced, with strong peaks, as you can see from this graph, in January, which is the summertime. That contrasts with Britain, where most of our diarrhea, which is caused by viruses, peaks in the winter. But if we look at our diarrhea, which is caused by bacteria, it's a minority in Britain, but a majority in many developing countries. You find it peaking, whether it's Salmonella or Campylobacter diarrhea, mainly peaking in the British summer. So it's not so much a difference between rich and poor, but between viruses and bacteria. The general rule seems to hold in all countries, that the bacteria peak in the warm season, the viruses in the cold season. And the fact that the bacteria in developing countries are peaking in the summer is telling us that they are multiplying. And if they're multiplying, they're not in water, because in water they die of starvation. They have nothing to live off. So the seasonality, by a complicated logic, is telling us something about the transmission routes. Two final arguments to clinch the case. One is the results of a study of fly control. My colleague Desmond Shavas tried fly control in a couple of villages up in the northwest frontier province of Pakistan, where there are huge numbers of flies in the summer. And it was a very expensive solution, so not a practical one, but it was what we call a proof of concept. It showed that if you could get rid of flies, you could, as he found, reduce the diarrhea by about a quarter. So if fly control reduces diarrhea by 24%, that 24% was being transmitted by flies. It was not being transmitted in water. And finally, we get to the hand washing studies where people have been encouraged to wash their hands with soap, or people have been seen to wash their hands with soap. So there are intervention studies, but also observation studies. And if we put them all together in a meta-analysis, which is a graph, where each study is a horizontal line, and the width of the line, the length of the line tells you the range of uncertainty. So the short lines are the big studies. And along the bottom we put a logarithmic scale showing the degree of reduction in diarrhea associated with hand washing with soap. And if we then pool all those studies as if they were one great big study, we get the vertical dotted line in this graph. And you can see that it's at around 2, which means that the people who don't wash their hands have roughly twice the risk of diarrhea compared with people who do wash their hands with soap. So what can we conclude from all this in terms of the implications for policy? Well, first, I think the priority needs to go to the people who are furthest away from their water. Those are the ones who have greatest difficulty getting access to water in sufficient quantities for good hygiene. I would say, and it's a fairly arbitrary figure, we ought to get the water within a kilometre of distance, or within half an hour's round trip, which is about the same thing. When you get to that level, people reach a sort of plateau in terms of water quantity that they use on the standard of hygiene. Bring the water to a few hundred yards and it's still about the same. But the big jump after that happens when you get water piped into their yard or onto the plot or in their house. Then consumption doubles or trebles. So the first priority should be for the people more than half an hour away, and if everybody's within half an hour of water, then we should be thinking about house connections. That, I think, would be a much more rational way to allocate priorities in water supply.